Good morning and welcome everyone to today's webinar, Cutting Through the Hype, What Retailers Need to Know About AI, ML, and Pricing. My name's Mike Troy. I'm the editor of Retail Leader and I will be your host today. And this topic is a great one because references to artificial intelligence and machine learning have been coming thick and fast in retail these days, and really for the last year or two, I would say. However, there's a huge difference between the hype you hear from all manner of solution providers and the type of mature applied technology that delivers business results and engages customers. So to help us cut through the hype and understand what really matters are two individuals who are not only extremely knowledgeable, but they're also able to convey complex technology information in a way that is understandable and actionable. With us today are Wang, Principal Analyst and Founder of Constellation Research, and Jeff Moore, Chief Science Officer with Revionics. Ray has held executive roles in product, marketing, strategy, and consulting at Forrester Research, Oracle, PeopleSoft, Deloitte, Ernst & Young, and Johns Hopkins Hospital. He's authored a best-selling book, Disrupting Digital Business, that provides insights on why more than half of the Fortune 500 companies have been merged, acquired, gone bankrupt, fallen off the list since 2000. And he also writes the popular technology blog, A Software Insider's Point of View, which I would encourage everyone to frequent. And that's focused on how disruptive technologies and new business models are impacting brands, enterprises, and organizations. Jeff Moore first joined Revionics in 2008 as Director of Research, and he earlier was lead architect of demand management science at SAP, where he led a team of scientists and engineers in the integration of demand forecasting with numerous retail applications. Jeff was also a researcher and systems engineer at pricing pioneer Kaimetrics, designing solutions for markdown, promotions, and replenishment, as well as core demand modeling and forecasting science. So our plan for today is we're going to hear from Ray first on the ways retail is being impacted by the digital revolution, which includes AI and ML. And then Jeff will take us through a layman's approach to what AI is and isn't, and how proven AI technology enables delivery of prices that are highly relevant to shoppers when and where they matter most, while enabling businesses to recover margin elsewhere and structure for sustainable financial strength. As they go through the presentation, if something isn't clear, although it should be clear because they're, like I said earlier, they're both very good at conveying information in a way that's easily understood. But if something's not clear, I encourage you to ask questions, and we'll get to as many of those as possible at the end. Any that we aren't able to get to, we can follow up directly with folks, via email or phone call. And then also I want to let you know that the presentation will be available at the conclusion. Simply send an email to info@revionics.com, and we can send that out. And I can remind everyone of that at the end. And then lastly, please, at the end, complete a post-event survey to win a Starbucks or be eligible to win a Starbucks gift card. With that, I'm going to turn things over to Ray. I will be back at the end to moderate the Q&A, and I'm going to let Ray take it from here. Go ahead, Ray.
Hey, thanks a lot. So good morning, good afternoon, good evening, wherever you are. We're going to talk a little bit about what retailers need to know about AI, ML, pricing, cutting through the hype, really talking about what's happening in terms of the world of digital and how this ties back. One of the things we want to start with is that this is not a fad. This is something that's been going on for quite some time. We're seeing a lot of improvements, and the companies that have built out artificial intelligence-driven business models through using pricing or next best action, the ability to do that, we've created a winner-takes-all market, not a digital divide. In fact, those companies that have done that have succeeded by taking 70% of the market share up to 77% of the percentage of profits. And they do this not by luck. They do this not by art. They do this by science. And it's the blending of understanding the natural dynamics and the ability to keep testing and figuring out where they can continue to make improvements, not just in figuring out new margin, not just in figuring out new types of next best actions, but it's the ability to do that on a consistent basis and doing that with science, not magic. And I think that's the important thing to learn here. But let's take a little bit of a look as to how do we get here? Why is this so important? Some of the lessons learned in AI, artificial intelligence, ML, machine learning, they're all part of the same subsets. So I'm going to start by talking about, why this is not an easy thing to do. Now, when we think about what's required for artificial intelligence success, using this in all types of models, there are a couple of things that you need. The first one is access to large corpus of data. And what I mean by that is your pricing data, your data sets, your SKU information, any context that you have in terms of the purchase, any channel information. I got to bring all that together, right? The second part is, now I've got it all in one place. How do I get that compute power, right? How do I crunch that information? And we're not talking about you crunching it, just a little bit of information. We're crunching a lot of information all the time. And that takes us to the third piece, which is time, right? This is not like a batch job you do once a week, you load it up into the system and you look to see how it's doing. We're talking not batch, we're talking not near batch, we're not talking about near real time, we're talking about how can we do this in real time and in some cases predictive, being able to do that in right time. And that first three areas that are listed here, the beauty is that that's starting to happen with compute power in data centers, compute power in the cloud, depending where you want to do it. Now, the fourth part is important because the fourth part talks about some of the math talent that's required, and that's kind of an important piece because the math talent does become important. So sometimes you get it from, you bring a data scientist on board, you train people on your teams to be good at that. In other cases, you go out and you train other folks to be successful on this, or you get some consultants and folks to actually make it work and get you all ready and up and running. Right? Those become very, very important. And then, of course, there's industry-specific expertise. That is your secret sauce. That is your ability to go out and figure out, how does this apply to my segment of retail, my segment, whether it's fashion or apparel, whether it's, if you're in the fast food business, if you're in consumer, quick service restaurants, it doesn't matter. The point being is, can you get that specific experience in place to apply to those models? And then we'll talk a little bit about natural UI and UX. Those are conversations as a service, the ability to, view different types of, experiences through augmented reality. Okay, that's fun stuff. And then, of course, recommendation engines or contextual decisions, right? Both of those are very important. Contextual decisions are where we figure out next best action, right? Do we do a markdown? Interesting. Not now. Do we actually keep the price, hold the price? Do we raise the price? How do we put all that together? That's the kind of stuff that we're trying to figure out. Now, why is this hard? Well, it's because we've got to figure out how to actually do this in an efficient way, right? And the battle for the most efficient compute power actually tells you who wins both in the cloud and AI. So let me tell you a story about the letter A. And this is kind of a fun story, and this gives you an idea of how far we've come with artificial intelligence and machine learning. So way, way back in the 80s, I spent a summer at Caltech. I got there, and I bumped into a team of folks that had just finished defending their thesis. They're all excited. We have a little party. And we get there and we ask them, what's going on? And then they said, yeah, we got this computer. Remember, this is in the 80s. We got this computer to figure out how to recognize the letter A. I was like, oh, that's pretty cool. Yeah, they spent 3 years doing it. It was a big project. They got all this compute time. Okay, it's kind of cool. So an hour or two later into the evening, I'm like, what in the world are you going to do next? You just figured out how to get a computer, read the letter A. That's awesome. So what do you guys think it was? All right, I'll give you a second to think. No, not the letter B. Lowercase a. Even worse. I can hear groans right now. All right, but anyways, you get the idea. So the good news is a lot of the compute power wasn't there before, but the algorithms were. The pricing models were there. The predictive analytics. The good news is all that stuff was figured out in the 80s. And the compute power is now here today in the cloud. And that's why this makes it so powerful. That's why we're thinking about, why it's so easy to be able to access this. It's not just about having to access this massive compute power. The beauty is it's here today, ready for you to get there. Now, why do we want to do this? Well, the ultimate goal is to augment humanity, right? What I mean by that, it helps us make better decisions, helps us recognize patterns that we didn't see before, help us figure out who we should be working with better, improving customer experiences, or thinking about improving back-end supply chains, right? And this is why this is so important. Now, AI is the new UX in some ways. We're now taking everything from our ability to talk, our five senses, right, ability to see things, ability to touch things, smell things, even taste. All these five senses are actually being digitized and replicated. And by doing that, it gives us the ability to actually go out and do amazing things. If you think about things like, if your ability to talk to conversations as a service, people are talking to these speakers, right, and they're talking back. It's like, anything from your phone to home stereo to home speaking systems, right, that's natural language processing. That's the ability to speak and actually take commands. That same thing's happening in, believe it or not, vision, right? The ability to recognize patterns on a store shelf, the ability to recognize buying behaviors, facial expressions, how people are thinking, right? And we also have even smell and taste that are actually popping out. These are real things where these are sensors that are figuring out, oh my God, it smells bad in the room, does it smell great in the room, are people excited? So just know that that stuff's coming on the consumer level. Now, why are we actually doing this? I'll give you an idea of actually how this all comes in together, right? And I'll give you, this is one example of using AI-driven smart services to power business model disruption. But a great example is, I'll talk about, for example, showers. Now, why am I talking about showers? Part of the reason I'm talking about showers is it's actually kind of fun. We actually had a client that actually wanted to put sensors on showers. Right? And the reason they wanted to put sensors on showers is because they wanted to be able to charge people $1 per shower head amount to monitor the showers. Now, that's a kind of interesting thing because it's not like they're trying to pay for showers by the hour or the minute or anything in that regard. But what they discovered that in hotels and in hospitality, that 4 out of the top 10 NPS scores are tied back to the experience in the bathroom and the shower. So the water's too hot, the water's too cold, the pressure's bad, it's leaking, all those things become important. And so by putting the showers up and putting the sensors into the showers, they can do a lot of different things, right? They can see how people are experiencing their environment, and if you can improve NPS score by 1 point, you can drive revenue up 13 to 21%. But there are other things that you can do that are very interesting here in the shower, because as you're monitoring the shower, you can also manage the service contracts. And you can take that to figure out how these showers are working and sort of, from an AI perspective, like, okay, is it working? Are they efficient? Are they not efficient? Are there parts in place? Does that make sense? And then we can ultimately get to some very interesting things, such as how long people are using the showers, and can we actually tie that back to loyalty programs? And the way that actually happens is, if you think about it, how many of you actually go in, take a shower, and sometimes leave a shirt or a blouse in the shower because you're too lazy to steam too lazy to actually iron, but you feel like steaming would be a better option. And so some people do that. And it's actually kind of interesting. And, next thing you know, it's a 5-minute shower becomes a 30-minute shower, becomes an hour shower, and it gets crazy, right? People are using a lot of water. Now, why is this interesting? Because you can actually tie pricing and rewards and loyalty to all these systems. Because if I told you, if you kept your shower to 10 minutes, I'd give you 500 reward points. And if you kept your shower to like 15 minutes, I'd give you 50. And after that, I wouldn't give you any more reward points. Would I change your behavior? The short answer is probably yes. And you can actually see how this works. And so by taking the signaling off IoT, figuring out these different price points to see how people would react, you now have the ability to actually create different business models leveraging this. First part, improving customer experience. Second part, trying to improve the way you actually do service because you're monitoring to this. Third part, you'd set up a plumbing network to actually solve these problems. But it's the green efficiency play because you can modulate things and the loyalty program that become important. And you can see this happening in every place in terms of how you do from coupons to redemptions to pricing to different line models. And by doing this, we're actually seeing a couple of things. Lots of folks are starting pilots in artificial intelligence and in machine learning. And these pilots are important because people are now focusing on different ways to get there. And one of the lessons that we've seen from these pilots is the fact that you've got to have different teams in order to be successful. And each of those different teams do something differently. So we usually typically have a team that is what we call our sustaining operations team. And the sustaining ops team, these are the folks that make things happen. It's 90% of your employee base. These are the folks that keep the lights running, keeps the trains on time, they're keeping everything pretty efficient. And these are the folks you have to win over ultimately. Secondly, we have a team that does incremental innovation. They came from the sustaining operations team. These folks keep the lights on, but they're also Six Sigma experts. They're the gurus. They're the ones that can squeeze out a 10, a 15, even a 20% gain. But now we're talking about disruption. We're talking about changing this market, doing something differently. We now have to look at this in a different way. And so what happens? We get a team that's actually out there that's doing transformation. They're a little crazy, right? They don't follow the rules. They don't color within the lines. And so ultimately, we've got to bring these three teams together. But the sustaining ops team and the incremental innovation team always look at the transformation innovation team with a little bit of skepticism, like, are these folks for real? Are they really going to do this? Is this just a pilot? And the trick is to bring them all together. And that's one of the first lessons that's important as you're thinking about embarking on these journeys. Now, what does this mean? Well, what are we ultimately trying to do is get to these AI-driven smart services, right? And getting these AI-driven smart services requires two things that are important, right? This is really about thinking about how we're going to change our business models by changing the way we use artificial intelligence and machine learning. As you know, I keep interchanging those terms intentionally, to really change your business models, right? Changing the way you look at, how you actually serve up your products, you look at your pricing, and you get to those areas. Now, let me walk you through a quick way to show how these new AI-driven business models actually work and these AI-driven smart services work. So there's three things that you actually need to deliver mass personalization at scale. It's one of those holy grail items that we've always been looking about in the digital world. First one is context. Tell me the roles, the relationships, the time, the location, the weather, how you're feeling, your sentiment, right? And when we put that together, the more relevant we are, the more likely people will engage with us, and the way we can actually move from real time to right time. The second piece that's important is, remember those choose your own adventure books? Those are great. You start on page 1, you go to page 17, you go to page 93, come back to 30, go back to 5. Bottom of every page was a choice, and it took you to a different journey. And at the end of each journey, right, what's interesting here is in the digital world, every choice is a demand signal. You know the context of something and why it occurred, and you actually know the path that they took, right? And that ties us to the third item, which is important, is what we call intention-driven design, or the ability to actually get to attention or anticipatory analytics, which not just capture people's attention, but it kind of guesses to what people will do. Now, remember Wayne Gretzky? He was a famous professional hockey player. Someone asked his father, why is Wayne such an awesome player? How does he know where to go all the time? Well, he just said, my son skates to where the puck will be. And that is probably very profound, but the point being is, using all the different factors, he would make educated guesses about where he needed to be successful. Let's take a great example here. How many of you actually purchase coffee in the morning? Buy it, the real stuff, you don't get it, not the free thing. Okay, so if you go into and get coffee in the morning, what actually happens is that, you probably get the same thing all the time. There's a pattern that occurs, right? And so I can make a guess and say, look, 7 in the morning, you get a tall white, totally understand. Every morning, that's what you get. That's your thing. So with a 90% probability, you get a tall white. Now, the couple things that have occurred since then, we know that you always get that, but the weather got a little bit warmer. So instead of being 60 degrees, we're now in the summer, it's now 85, 90 degrees. I want to see if the weather actually changes your decision. If it's 80 to 90 degrees, will you get an iced coffee? Now, some people may say no, but there's a 70% probability you might. So let's say you say no. Let's say, oh, that's kind of interesting. Now it's 100 degrees outside, you're in Phoenix, and say, hey, would you like to get an iced coffee? And you actually say yes. I know that you're weather sensitive. But if it's 100 outside and you still say no, I probably won't make that offer to you again. So the first offer, 90% tall white. Second offer, hey, it's a little bit warmer. Let's try an iced coffee. There's a 70% chance you might do that. And then there's a wild card that says, hey, look, maybe you like a scone. I'm just kind of curious. I'm going to do some testing. You see how I took context, choices, and anticipatory analytics and put that together. That's the power of what we're trying to get here, right? Getting to that AI-driven smart services. Now, another great example, walking into the lobby of a skyscraper, it's 2 in the afternoon, 27-point facial analysis, scans me, it looks at my gait analysis, it says, hey, I know, it looks like the guy on the 15th floor, it's 2 in the afternoon, more context, you know what? He's in the lobby. Let's send an elevator down because he might need one. Let's see how we're doing with the elevators. Perfect, right? That's what you want to get to. I swipe my badge. It says, oh, look, it's Ray. Perfect. He's on the 15th floor. There's a 95% chance he's going to the 15th floor. But you know what? I've been trying to meet with my boss. She's actually on the 25th floor. I've been trying to schedule an appointment with her for 3 weeks. There happens to be a window open. So there's an 82% chance I might actually want to meet with my boss on the 25th floor. Woohoo! But wait, there are free donuts on the 5th floor. What do I do? All right, so you get it, right? This is really what's going on. Here's the secret to every single AI-driven smart service, driven by mass personalization at scale and pricing models. Give me a little bit of your digital footprint and your digital exhaust. Give me just a little bit so I can segment and make this educated guess. I take that, I apply AI and cognitive reckoning, and then I look at immersive experiences. I didn't say omni-channel. Notice I didn't say that. I said immersive experience. I take a little bit of context. I use that context to surface up something for you to engage in, which is the content. You then engage, which is collaboration, and then I deliver it across multiple channels. I could be in the elevator. It could show up on my phone. It could show up on the console. It might even show up in my ear. And then we deliver on personalization at scale. We apply anticipatory analytics. We take those guesses to say, okay, where was this puck going to be? We provide some catalysts, which are really the point of the offer to get people to actually respond, and then we give them a bunch of choices. Once we have that in place, we get to the cool part, which is value exchange and pricing. Sometimes it's monetary, right? How much is it going to be? What's the cost? Sometimes it's non-monetary. I'm actually trading a favor, and sometimes it's consensus. We made a decision. We scheduled an appointment. And when we get that in place, we apply cadence. We say, when did that happen? How often does that happen? Is that a repetitive process? Is that dependent on something? And then we take that and we apply machine learning, and we bring it back together. And once we do that, this is the beginning of how you deliver mass personalization at scale, right? And how you think about what's the next best action on the pricing monitors. That is beautiful. And I think that is wonderful. That's how we get there. Now, what are we ultimately trying to do? With AI, we're trying to get to outcomes. Start by telling me what's going on, what's happening. Then I want to know, give me a notification. Give me an alert. Once we get to that point, you know enough about me. Make a suggestion, make a recommendation, and then we want to get to automating those recommendations. Right? Because you don't want to be there every time manually adjusting this. You want the system to get to know you and be smarter. And ultimately, we can make some predictions to guess where we're going to be, and then we can do some cool things around prevention and risk and compliance. And then, of course, we're trying to get the situational awareness. Let me give an example on this prevention piece. Let's say I am allergic to nuts, right? Well, you know what? My coffee place will never, ever surface up any food that has any nuts projects or processed by nuts. That's an example of prevention. Think about how many lawsuits you could prevent. Think about how many lives you could save from putting someone to an anaphylactic shock. That's the kind of power that we're talking about. Think about compliance, right? Just on requirements for pricing or requirements for marketing or requirements on privacy. That's what we're talking about, being able to get to that level. Now, there are a few interesting design rules as we think about AI and ethics. Want to share that with you before we get some really cool stats and turn it over to one of the smartest folks in the industry. So there are a couple of things. Design rules for AI ethics. There are a couple of rules with these algorithms that we think are important. The first one is it's got to be transparent, right? Understand the algorithm. People have to be able to see and understand why things happen. The second thing is it's got to be explainable. You got to be explained why certain actions and consequences have occurred. If you've got bias, bias isn't a bad thing. The question is, are you okay with the bias that it provides? Right? Bias takes you to a certain type of outcome, and if that's what you're trying to get to, it makes sense. But if you're excluding folks, or you're not including enough folks in certain ways, you want to make sure you can change that. And that's why it's important for these algorithms to also be reversible. And once that's in place, we got to be able to train these systems. One might argue that the average human male takes about 18 years to mature. All right, maybe 30, right? But you get the idea. These systems are complicated. We've got to figure out, you know, if they make a mistake, like how can we teach them? How can we learn them? Is it a self-training model? Is it a, you know, you just put them against a training model? And then the last piece becomes important. It's got to be human-led. You want to begin the process with a human and somewhere end the process with a human so that these systems don't automatically get out of control and that we actually have some checkpoints that are in there. Okay, so what's going on with AI? You've heard all the benefits. You know why people are doing it. We gave you kind of a model on AI-driven smart services. This thing is real. We did a survey, an AI survey that we actually published. You can find it. It's probably all over the web at this moment. But basically the point is that most folks are thinking and using AI. 70% say yes, right? This is folks that are actually doing machine learning, deep learning, natural language processing, cognitive computing. They're starting that process. And so AI is there. People see it as an exponential technology. It's going to make a big difference. Now, the interesting thing is, when you ask people who's actually investing in this and or investing more, what does it look like? Look at that, 78% are increasing more than 50% or less than 50% of last year. Bottom line, budgets are increasing for AI. People want to get to that. And interesting, market leaders are actually, and fast followers, those are folks that we see that are driving the market, the top 20%. They're already driving this, right? They've got their own data science teams. They got their math geeks. They've got all their folks figuring out how to build these open source systems on their own. They also, some of them, if you look at it, are buying cloud-based machine learning and AI services from software vendors who actually provide that out of the box. That's 52%. And there are some other folks that are just buying packaged apps with the AI capabilities. Right? All different ways to get there, all different techniques that are picked. People are doing it. So we see that. This is something that is happening right now. Now, why do they drop these things? Why do they adopt these in different ways? They adopt it because time to market. Right? If you don't have time to build out, your own pricing models in an open source framework with 20 math scientists, right? You should buy it, right? I mean, that's not your core competency, right? So some people buy those. They get packaged apps with AI capabilities. Other folks are building extensions to things that they've bought. So there's a lot of different models in there, not one place that everyone's going to, but lots of different experimentation and lots of different deployment models and lots of different successes using different techniques. For us, we actually recommend most clients buy it packaged, get it from a vendor that's actually doing it. It's going to save you a lot of time, and then learn from that. If there's things that you need to figure out and build out on your own, work with the vendor to customize it, configure it, or build it with your own teams to augment it if it's your secret sauce. Totally understand. All right, so what does this take us? We are disrupting digital businesses, right? And so digital Darwinism is unkind to those who wait. There isn't time to wait to do this. Every day you are running late behind this, your competitor is actually getting smarter, right? These systems are moving so fast. They're learning patterns and behaviors, right? And you don't want to be caught behind. Now, to an example of companies that actually have been disrupted, this is a great chart. Richard Foster at Yale, he showed that the average age of a company in the S&P 500 in 1958 was about 60 years old. Today, the average age of a company is somewhere between 15. It's trending to 12. There's a 3x to 4x compression in the average lifespan of these companies. And so the question is, how do we make that change? Well, you want to get started. So let's think about this. First thing, think about the experiences and outcomes you want to build, right? What does it do to reflect your brand? How do you want to reflect that in those experiences and outcomes people get? Second piece is we want to build a culture of a digital DNA. We want to make sure people understand that we're going from, we've got to have the right people to actually look at a holistic view of the problem, getting the right talent of digital artisans, left brain, right brain people. And then we can figure out how to build business models and technologies to existing infrastructure. We have to apply the right business model. And we think about the business model, and we've got to apply the right technologies to make that happen. And then we're going to move from gut-driven to data-driven decisions, especially on pricing. We now have the data to do that. It's such a powerful factor. And then, of course, how do we co-create and co-innovate with new partners to get there? Because you can't do this alone. And these are very, very hard things to do that. So as you can tell, a lot of exciting areas here, a lot of different opportunities to actually use AI and machine learning to actually disrupt what's going on and cut through the hype, right? These are the things that you need to know about AI, ML, and pricing to get there. And with that, I'm going to share with you quick information to get a hold of me, and more importantly, turn it to one of the smartest people in the business, Jeff Moore, who can tell you more about AI-powered solutions and what Revionics does. Thanks a lot, Jeff.
Ray, thank you so much. Really appreciate it. I was really excited to get to speak with Ray. So many of the points that he mentioned, resonate with me and with Revionics in terms of how we think about the problem of price and promotion optimization for retail. Revionics' story really is right along the lines of what Ray talked about, the confluence of data availability with cloud economics and increasing availability of tools and technologies, increasing scale of computing. All of those things are contributing factors to our success. But as much as that confluence of forces shaping some of the advancements in AI and ML, have supported Revionics in its vision and its product development, Ray also talked a lot about the ethical, pragmatic concerns that go along with delivering solutions that are workable, and he called out some really interesting points, when he talked about what's necessary: the transparency, explainability, human-led, trainable, reversible. When we think about these things, transparency and explainability are really key and very core values for us, and it's something we think about very closely in our solution. It influences a lot of our decisions about how we build UI and UX, how we present information to customers. We like to talk also about awareness of uncertainty within the solution itself, risk consciousness, and these are all some things we're going to talk about in the presentation today. So, we like to talk about what AI-powered solutions are, and it's useful to start by talking about what they're not. So just to put a flag in the sand here, AI solutions are not artificial generalized intelligence, AGI, or generalized machine intelligence, GMI. So too often there is an inclination to attribute to AI solutions some level of human intelligence or this general thinking or cognition ability that simply doesn't exist. Everybody who is a practitioner in this space is in total agreement that there's no such thing as AGI or GMI. And all the AI capabilities and solutions that are out there today are what are known as narrow AI. And in many cases, they're narrower than people necessarily realize. But, we've got artificial intelligence, we've got machine learning. Those two terms are used frequently and sometimes interchangeably. So we like to start by kind of defining what AI means. And very simply, we'll just read the definition. AI solutions are goal-seeking agents that seek to identify or implement decisions likely to produce beneficial outcomes as informed by the data in their environment. Pretty simple. These are incentivized systems that have a goal or outcome they're trying to achieve, and they use data to make informed decisions and make informed predictions about the consequences of those actions. So really, what's a goal-seeking agent? That's a fancy way of saying a software system that's been given agency or control over some domain of significance and consequence, where we're asking it to help us make better decisions or identify decisions that are going to help us drive towards outcomes that are likely to benefit us. What is a beneficial outcome? That's a pretty squishy term. We'll talk more about that because that gets into a whole area of discussion in AI known as a value alignment problem. How do I ensure that the AI solutions that I'm using are actually doing what I want them to do, that are delivering on results that are what I really want to see, and not producing unintended consequences, or are not configured to do things that are maybe a proxy for the real outcomes that I actually want to drive, but that may have attendant unintended consequences. And when we say informed by data in the environment and likely to produce, we're really talking about the ability to make predictions in the face of uncertainty. So we're leveraging data to make predictions about the future. Often those predictions are uncertain, and uncertainty comes with an element of risk. And so when we think about AI solutions, we think a lot about how we present uncertainty to the end users and how the solution itself thinks about risk in terms of making its decisions. And in fact, risk aversion versus potentially more exploratory fervor, those are actually elements of control that, as Ray said, these things need to be human-led, and that's a core value for us too. We think it's really important that at the end of the day, humans are making decisions about risk tolerance, about strategy, about long-term behavior in the system, and how it will influence the outcome. Because solutions are narrow. They're highly effective at driving outcomes within the narrow domain and the narrow window into reality that the data presents them, but they don't know everything. And so it's very important to think about the consequences of uncertainty, strategy, and human-led and human-directed outcomes. So when we talk about making predictions, really machine learning at the end of the day is a set of tools that we can use to make predictions. So machine learning has a whole bunch of attendant semantics. People think about supervised learning, unsupervised learning, neural networks, convolutional neural networks, random forests, et cetera, et cetera. Machine learning is such a broad topic area that it's worthwhile talking a little bit about what machine learning is. Really, machine learning is a set of problems that are reasonably well defined. So really, if we're talking about a prediction problem, a classification problem, or this whole other area called unsupervised learning, which refers to finding structure in data that is not immediately obvious. The difference with unsupervised learning is that there's no right answer. It's a way of understanding the world without having what are called supervised training sets, which mean we have labeled data that tells us the right answer in history that we're trying to get the machine to predict. So that problem set has a whole toolbox of tools that can be used to address these problems. So the tool set is actually quite broad, and we'll talk a little bit about some of the things that are in that tool set. Most of the time when we talk about artificial intelligence in a business context, what we're really talking about is incentivized applied machine learning, meaning that there's a machine learning algorithm that is using data to help it understand the world and help it to make predictions. And again, there's never a crystal ball. Predictions are always subject to uncertainty, and that becomes very important when we talk about how to build, deploy, and explain the outcomes that are being recommended by the system to the users of the system, who are really the ones who bear the risk of using these solutions and allowing them to take on agency over some of these problem sets. So ML, very simply, really boils down to the problem that we like to call what's in the box. The real world is a generating function, and for a certain set of inputs and a certain set of states of the world, the real world generates outputs. In a lot of cases, we want to know what that generating function is, and we don't know it beforehand. So that's really the problem of prediction in machine learning. What's in the box? There's no way to tell what the true generating function is, and there's actually a whole lot of philosophical discussion you can have about what you actually can learn, what is learnable from data. But we can approximate it really well, depending upon the tools that we use, with a machine learning model that we train using a history of known values. So when we talk about supervised learning, that means we've got a history where a set of inputs are associated with a set of outputs. We use that to train the model, and now we have a tool that can help us predict outcomes as a function of states. And those inputs can be anything we can give to the model. And as technology gets better and as data sources become more prevalent, we can actually feed more things into the model and improve our predictions from doing so. So what's in that toolkit? The toolkit is large and expansive. It's not one technique, it's many different techniques. We've called out and circled some of the things, some of the tools that we use at Revionics here. Random forests, we've used neural networks for some problems. Ridge regression, logistic regression, those are logistic regression is a probabilistic predictor. Some unsupervised techniques, including hierarchical clustering and k-means. These are all tools in the machine learning toolkit. In addition, there's some other ones that aren't called out here. One of the techniques that we've been doing a lot of work with recently that we're quite excited about is called Gaussian process learning. And we won't talk too much about what that is, except there's been a lot of talk about big data and the availability of data driving a lot of the work in machine learning. And that's certainly true. The size, volume, availability of data really are driving a lot of the work in this whole space. However, there's lots of problems where we want to extract the maximum amount of value out of a small amount of data. And Gaussian process learning is a very powerful technique for building models out of a small number of data points to help us maximize our understanding of the world based on a very limited set of data. And this is actually a tool that we've been using to solve some specific problems that really call for us making good predictions from a small number of data points that can be informed by some things that we know about the environment, which is a Bayesian technique and Bayesian framework, which we're big fans of. So, given that there are all of these tools in the toolkit, what's the right tool for the job? And the answer is there is no one right tool for every job in the machine learning space. The decision of what tool applies to a given problem really has to do with a whole set of trade-offs. And the job of a data scientist, above all, is really about understanding these trade-offs. Different tools vary in their predictive power, what we call expressive power. How many functions can they represent out of all possible functions? How robust are these solutions to data that's not necessarily friendly to helping us build a model? You know, we have another saying at Revionics: the data is not your friend. Data is powerful. Data is, you know, the food that machine learning lives, grows, and thrives on, but it's not always there to help you build the best predictive model. And the robustness of the techniques you choose and select, you know, really is something that a lot of thought goes into at Revionics in terms of what tool is going to work well given this problem, this data set, and the unique characteristics of that data set. So that goes into what training data is available, you know, how much information can we extract from the data that's available. You know, computational complexity goes to performance. You know, as Ray said, computational complexity and the tools to allow us to scale computing have gotten much better. You know, Revionics has been doing horizontal, massively parallel compute since its infancy, but that said, computational power isn't yet infinite, and there are still cases where we have to care about the computational efficiency of a given algorithm, and if we can do almost as good of a job with a tool that's got a much lower computational burden, that may be a good choice in some cases if the alternative is going to take more time than we want to spend to get to the answer. Again, thinking about things like immediacy and making the right decision now, that's something that comes into play when we're talking about real-time decision making. And finally, transparency. You know, this is a topic of great interest to us, and it's something that our company has been built very heavily around the idea that it's crucial for business users to have transparency to the recommendations coming out of the system. And it's a key distinguishing feature of the solution that, you know, we think an awful lot about how, from a UI perspective, we can explain what are the drivers, what is causing us to recommend this action, how certain are we of the outcome, how much risk is associated with the choice that we're advocating. These are things that we put a lot of thought into and can also, in many cases, dictate the choice of the tool. Some tools are really good as predictive engines, but are more what we refer to as black box and maybe don't give you the level of visibility to potential risk or uncertainty, or don't have the awareness of where they do well, where they don't do well, et cetera. So those are kind of the pragmatic considerations that come into play when bringing tools to bear in these problems. So, you know, we talked about our definition of AI, and at the end of the day, the differentiation we make between AI and ML is really AI is just incentivized application of machine learning. Machine learning is about building a predictive engine from data that helps us predict outcomes. AI is the direction we point that engine in telling it what outcomes we want to achieve. So what is a beneficial outcome? This is actually a much harder and richer question than it might seem. Again, the window into the world that these algorithms have is dictated by the data that we can feed them. They don't know everything. So when Ray talks about the notion of human-led AI, we think it's very important that humans still have agency and control. We think that strategy, long-term direction, and even telling the system what the outcomes are. Do we want to drive more for profit? Do we want to drive more for volume growth in revenue? That has contextual elements, some of which the system may be able to see. We may be able to tell it some things about market share. We can tell it some things about how our competitors are pricing. But it doesn't know everything, and that's where we can leverage, you know, the human domain experience and knowledge of the market, knowledge of the competitors, knowledge of the consumers, and be able to leverage that to shape and direct the actions that the AI is advocating and the actions it's taking on our behalf. You know, likely to produce becomes a very important question because in all cases, these machine learning algorithms, even the most powerful techniques out there and available, are always making predictions with some level of uncertainty. So the likely to produce is actually a very interesting little asterisk on the definition of artificial intelligence for us because it implies a lot of things about uncertainty and risk and the extent to which the solutions are aware of that uncertainty and take it into account in making their recommendations. That goes directly into the last question of, can I trust the machine? And certainly from Revionics' perspective, one of the most powerful things for the adoption of our solution has been that we have not only the transparency, but also the human ability to decide how much risk they want to expose themselves to as a function of the uncertainty. So you have to have a transparency first. If you can't tell the users your level of uncertainty or the risk associated with a decision that's being advocated, then they can't control it. But we think it's important not only to highlight the uncertainty in a given recommendation and tell them how much information we're able to derive from the data and how much inherent uncertainty there is in outcome from the solution that we're recommending, but to give them the ability to decide how much of that risk they want to bear. There's pros and cons. You know, these machine learning systems are fundamentally learning engines. We like to talk about online learning. They can learn and adapt, and having a greater risk tolerance can actually allow the system to get more data points, more diversity of data, and get a better understanding, to tighten the confidence bounds on future predictions. So being more risk tolerant can actually allow the system to learn more quickly, and we can actually show and demonstrate that in the solution that over time the system gets better and confidence bands get tighter as we make more recommendations and get more and better data fed into the engine. You know, naturally our predictions get better and consequently our recommendations get better. But that said, at the end of the day, there are areas where we may not be willing to gamble with customer perception or customer price image. And really we think that that's very important that that be up to the human-led component of the solution to dictate and decide how the system should respond and behave in the face of uncertainty. So really, AI-powered solutions to us are, again, applied machine learning that's incentivized to get some outcome with a big human-led component there to say what are the outcomes we're looking for, what strategy should we take, how much risk should we take, what are the guardrails that we should put in place. Those are all important considerations. And so the pragmatics of delivering successful AI-powered solutions have a lot to do with the sensibility, usability, their cognizance of risk, their transparency in explaining the recommendations, and really the way that the solutions interact with the end users and the way that the end users have the ability to interact with the solutions is as powerful and as important as any of the nuts and bolts of the machine learning science that underlie it. And so that's something that I think Ray and I are both in great agreement about. So with that, I'm going to hand it back to Mike, and we'll get into some questions.
Cool. All right. That was awesome. I love how we went from shower heads to Gaussian process learning. That's interesting examples there, but all good stuff for sure. I want to remind everybody, if you want the deck, the email info@revionics.com. Shoot a note just in the subject line, mention the webinar, and we can get you the deck over. So we're going to take a few questions. We've got about 10 minutes, so we can get to quite a few, I think. I'm just looking through the log here. Let's start with this. How does competitive pricing factor into the science?
Yeah, so I can answer that one. I mean, competitive price is what we call a causal driver. We can bring it in as a modeling component and look for the sensitivity of demand to the price gap. So in addition to the absolute price of the item, we can look at how competitive prices actually drive changes in demand, basically substitution to competitors. So you can think about that as a causal driver. How we want to position against competitors is something that, again, going back to the human-led component of strategy, is something that we take a lot of cues from the end users about how we want to posture against a given competitor. But we can also inform some of those decisions from data. We, in fact, have a service called Competitive Response Analysis that attempts to do exactly that. It basically highlights the level of competitive price sensitivity for various competitors, 10, 20, 25 competitors, and will basically show us what areas of the business and what types of products demonstrably in the data evidence switching propensity, meaning that when we see a big gap against the competitor, we see significant extra elastic shifts in demand. So we've got an analytical service that basically tries to identify all of those areas in the business that are most impacted and by whom as a competitor. That's a great example of an approach to using data to inform some of those decisions, but at the end of the day, the human component of strategy, understanding the consumers, understanding some of the market positioning, that's also going to be a crucial input when we think about how we're going to position against competitor A or competitor B. But we certainly think about competitive price as a data element that we can build into the machine learning models to help us better understand who the key competitors are and what areas of the business we need to pay attention to competitive sensitivity versus those areas that consumers basically don't seem to be as anchored to a given competitor.
Okay. Can you talk a little bit about maybe some quick examples of how you put guardrails on AI solutions?
Sure.
The human factor there.
Yeah. So in the Revionics context, pretty much any solution provider in these kinds of spaces, particularly ones that are coming from traditional operations research kind of backgrounds, are going to think about the solutions in terms of constrained optimization, meaning that we're trying to get an outcome based on some objective of driving profit or revenue growth or whatever the objective happens to be. But we're going to do that subject to a set of constraints, and those constraints can be up to and including putting hard boundaries on relations between products in terms of the gap. So we have things that we like brand relational rules that let us say, we think that the national brand should be, roughly 20% higher than the private label product, plus or minus 10%. Those are the kinds of guardrails that we can put on the solution. And one of the things that we do in our solution is we allow the end users to make those either as tight or as loose as they want. So we have a notion of both what we call soft constraints, which are kind of structural targets along the lines of, this brand should be 20%, 30% higher than this other brand as a loose indicator. So when the system maybe is not as confident of outcome, that can actually become a stronger driving factor in the ultimate recommendation. But when data is stronger, again, it's entirely up to the end user to decide how much freedom and flexibility they want to give the system. But the system can be allowed to deviate from those targets and guidelines to a great extent if the customer allows them to. But again, we have a notion of both soft constraints and hard bounds-based constraints, where the distinction is bounds-based constraints, dictate a specific range over which prices or promotions are allowed to operate. The system will not recommend anything outside of those boundaries. So we do both. Again, there's a trade-off there. By allowing users to configure guardrails, they can have total confidence that the system can't do anything crazy. It can't operate outside of those guardrails that have been set. However, the trade-off there is they may be leaving value on the table, and the data may be telling us that we really can, go outside the bounds of those, configurations. So the services group at Revionics and the pricing strategists, their main function is to help users get to a set of strategies that reflect what they're trying to do in terms of the outcomes, and then to also configure the guardrails to find a pragmatic balance point between governing the system and what it can ultimately do, putting some guidelines on how much freedom and flexibility the system has to make data-driven decisions versus allowing the data to speak and really getting the best outcomes based on what the data is telling us.
I just wanted to add something real quick.
Yep.
I just want to say real quick. I think the way to think about guardrails is that wherever you want to make sure that you're trying to avoid a false positive or a bias or something that's in place, you just want to make sure that you're training the system to a point where you're confident enough that something is going to happen in the direction that you want. And it's really important to think about guardrails in the design as you build out your systems. So.
Well, that sounds like what Jeff was talking about, with the whole balance between transparency, uncertainty, and risk. Here's another question. I think this one's maybe for you, Ray. Where are we at? How mature do you think retailers are when it comes to leveraging AI in their business?
I think it really depends on how well retailers have leveraged their data to start with. So the retailers that have worked hard in the past to get data prepped, to thinking about anything from getting their predictive analytics in place, they're in a wonderful place to take advantage of AI, especially as they bring in new sources of data and information from outside systems. They're in the best place to actually make that work. The ones that have just gotten started or kind of ignored the data problem and don't really have a good way of actually bringing and capturing all that information, they're going to need a little bit of help. And I think if you're in that case, it's going to take you about, some time to actually get the data ready, but it's time to get started, because every day that you're not up and running and leveraging this data and insight is a day you don't know how to price something. It's a day you don't know which products actually should be promoted better. It's a day you don't know where you should actually get discounts to drive down supply chain. It's basically a day where you're running blind, and you don't want to be in that situation, especially today, given how everything is built on these data-driven business models.
Okay.
Yeah, just to echo Ray's point, as going through these engagements with retailers, we spend an inordinate amount of time talking about data, sources of data, quality of data, richness, and granularity of data. To Ray's point, the data is everything. The data is the window through which the machine learning algorithms can see the world and try to understand what's happening, and they live and die on the quality of that data. So again, we build systems and solutions that are risk aware, that are conscious and cognizant of their own uncertainty, but at the end of the day, the data is going to dictate what we can do and how well we can predict outcomes. Better data leads to better outcomes, is really the punchline of that discussion. And we spend a lot of time talking about sources and quality of data with the retailers we work with, because of you can't overstate the importance of.
Yeah, well, and we're getting more data all the time from more sources, so it's certainly interesting. Here's we're going to run out of time here, so let's get to a couple more real quick. Do you model base price elasticity and promotional elasticity separately?
Short answer is yes. We have a different treatment of promotional response in the model that is generally, when people promote, they get what we call an extra elastic response, meaning that you'll get a higher proportion of demand response for the same level of depth of discount when you promote. In fact, that's a very fancy way of saying something that's fairly obvious to people. That's part of why you promote. You can get an inordinate response by drawing more attention to a price discount, and that's specifically why they do it. But the short answer is yes, the models treat promotional price response fundamentally differently. In addition, we also look at the circumstances of how the item is promoted, because that has a big impact on outcome above and beyond just the discount. So that goes to whether it's in-store signage, whether it's just on-shelf promotions, whether it's in a print circular, has email support. And again, going back to data, the richness and granularity of the data related to promotional activities in the history really dictates the granularity with which we can make predictions and measure outcomes related to promotional activities.
Okay. All right. Let's one more question. We can end on this. How can AI work in a retailer environment where data is maybe scarce? Because retailers have varying degrees of data and their ability to work with it. For example, fashion, where inventory turns or there is limited promotional data.
Ray, do you want to put any thoughts? I definitely have thoughts on that, but I'll let Ray answer first.
Yeah, I think you start with the data you have, and you try to solve problems from that, and then you try to figure out what data you don't have. And one of the ways and techniques to do that actually works well is you start by asking questions you normally wouldn't have asked in the past, right? Because we don't have the data, and you start with those business questions, and then you start figuring out what data sources are missing. That's probably the best way to do it, and figure out why they're missing. But you start with what you have, and then you start building around the areas that you need, and that's typically how people get started.
Yeah, that's a great response. And our group has been doing a lot of work in the short life and apparel, highly seasonal merchandise area. As you said, when data is scarce, there's limits to what you can extract from new items. We're big fans of what are called hierarchical Bayesian techniques, which allow us to provide a path of inference from other items, other similar items. And we've been doing a lot of work with what's called attribute-based prediction, where we can use product attributes to basically infer similarities. So if we've got a product that's brand new and we don't have any demand history, it may be very similar to some other products that we have seen before. And that's actually a pretty active area of work for us, is doing a better job of making predictions on short life merchandise, where we're having to make predictions based on very little data, directly observable on the products that we're talking about, but we may have a wealth of data of similar products from past seasons. But the extent to which that we can apply that and how to apply that past data, again, comes back to richness of data and sources of data for things like product attributes that can allow us to do that kind of broader inference.
Okay. I think we might have to have another webinar on hierarchical Bayesian techniques. That sounds like a whole nother topic. Yeah, but no, this is awesome stuff. Thank you, Ray. Thank you, Jeff. I know this is deep material, and we covered a lot of ground, so I'm sure folks have questions. If, final reminder, please email info@revionics.com for the deck. And with that, thank you, everyone, for your attention, and have a great day. Thanks.